welcome to GS 106. This is the lab on volcanic explosivity. So on Tuesday or Monday or whatever day it was that we had lecture on volcanoes, I told you a lot about volcanoes. And so here's a lab that we're going to do that's going to model how volcanoes generally behave. We have 3 volcanoes here. Look at these amazing green volcanoes. And so the idea here is we're going to be adding different amounts of Alka-Seltzer to each of these volcanoes. And so obviously, if you have really bad indigestion, you take more Alka-Seltzer to try and tamp it down. You're going to, in this instance, we've added soap to this lukewarm water in each of these volcanoes. And when we add the Alka-Seltzer, it's going to create gas. And so if you remember, the more silica you have in a volcanic system, the more viscous or sticky a lava is, and the more easily it traps gases in the volcanic system. And that makes it more explosive. And so that's what we're going to try and model here to show you how you would model and illustrate high to low levels of silica in a volcanic system. So we're going to start here, and I'm going to break this guy up. There it is. I'm going to cover it with this saran wrap, and I'm going to tie this rubber band around it a bunch of times, and we're going to wait 20 seconds. 1, 2, 3. So we can see in here there's quite a bit of gas building up. You can see that this is kind of bubbling up, and I think we're getting to about 20 seconds right now. So you heard there was a little pop, and we're gonna, maybe we should have waited a little longer. We can see that all this foam is zooming up to the top. And okay, look at that. Okay, so this is what we call, this is like a flow. This is a flow of lava, and we call this effusive. It's just flowing out of the volcano. It's not very explosive. So initially, we may have had a minor explosive part of the eruption, but this is mostly a flow. So this would be a lot like how basalt behaves when it comes out of, say, Mauna Loa in Hawaii. So plume height, well, we didn't really have much of a plume height there. At the most, we're going to say, maybe half a centimeter. And then I'm going to go ahead and measure this. I'm going to measure each of these and provide you that data in a table up here on the board. So I'm going to go up here, and we're going to record this. This is in centimeters. We said 0.5 centimeters. Okay, and we'll record all that at once as far as the taproot volume goes. Go and move on to the second volcano. This time we're going to try 2 tabs. And you can guess that this is probably going to react fairly quickly. And so I have to, and Tony, you're probably going to want to step back in this situation. And so what might be your intuition if we have more gases trapped in this system?
It's going to be more explosive.
It's probably going to be more explosive. Yes, very good. You're smarter than I thought you were.
Thank you.
You are so welcome. Okay, look at all that. Look at all that gas building up. Okay, this is going to be very explosive. Are you ready? Look at that. Oh, that's a plenty eruption. Look at that. Wow. So amazing. So, what do you say we got up to right about here, Tony? Whoops, I'm measuring the wrong way. About 25 centimeters. And it's still, so we exuded a lot of this. This would be ash and pyroclastic material that came out initially. And now it's just kind of, the lava is just flowing out. So we exuded a lot, we erupted a lot more material with the added Alka-Seltzer volume. So what did we say that was? We said about 25 centimeters. I'm gonna go ahead and write that over here. Well, that really makes me nervous about what the next one's gonna do.
I think I'll just zoom in.
You're gonna set that one out?
I'm just going to zoom it.
You're gonna zoom it. I gotta steal this rubber band here because I think I need a really powerful one for this. Okay, so I have to act really quickly here because we saw how powerful the last explosion was. 2, 3, 4, 5, 6. I'm not feeling yet. Oh, I'm working on failing though. Look at this. I'm gonna do it super tight. It doesn't. Oh shoot! I'm failing. No, I'm not. I'm actually succeeding. Oh no, I am failing. Oh, one more. Oh wait, no, that's gonna have to do. Watch out. So you can see it's coming out the side already. It's doing the Mount St. Helens. Look at that. We're gonna capture this. Okay. Lot of, boom! Oh, it hit the ceiling. Look at this. Oh my goodness. Oh my goodness. Oh wow. Ultraplenium. Very powerful eruption. That was amazing.
Amazing.
Amazing. So our plume height with all that gas, and my dog doesn't like that at all. I would say that's about, let's see, 80. It's about 87 centimeters. And it's going to take me a little bit to collect all the tephra. But yeah, we can see the trend here. We erupted a lot more material with the more explosive eruption. We erupted, and a lot less with just one. Which is just one little puddle here. So if you wait, just wait a second, we'll measure this. And so here, I'm gonna just pour this material, all this tephra. It's super hot. Just, ow, no, just kidding. So yeah, maybe 1 centimeter or a milliliter, okay? Maybe 1 milliliter. We'll pour it back here. And we're going to come over here. Now, obviously, we lost some of this tephra to the side, but there's not much we can do about that. Okay. So I'm going to pour all this tephra in here. And this is number 2. And what do we have? About 12, maybe 10, 11. I got to look here.
Like 12. 13 maybe.
No, it's got it. Well, I guess if we include the foam, yeah, let's go with 13 there. pretty cool. I'm gonna pour that out. I gotta go wash the foam out of here. And then we'll just measure the last one. So what did I say? We had one. Let's write this up here actually, so we don't forget. We don't want to forget. We don't want to forget that last eruption. Wow, amazing. 13 milliliters. And now we're going to collect the gigantic ultraplenian eruption tephra. I'm going to grab this towel here because we have so much that came out here that I have to add this to the content here. We want to be as precise as possible. Obviously, there's going to be some error in our measurements here because we couldn't capture all the tephra. But yeah, we have enough data to get a ballpark idea of the general behavior of different volcanoes as we have more silica in the system and trap more gas. Okay. So this is number 3. And wow, it's a lot. That was so fun. I hope you had as much fun as I did. Okay. So if we count the foam, the foam will go down. Let's call it 70. The foam is something that came out of the volcano, so let's count it. So, and what did we say? 87? I can't remember. I think it was 87. So you can see the trends here. The top is less silica in the system. This is more like the shield volcanoes or the rift eruption, shield volcanoes in Hawaii or rift eruptions at mid-ocean ridges are going to be relatively porous silica. But then as we start to involve more silica-rich minerals and rocks, the lava becomes more viscous, more sticky. When you saw that this was just a flow, this first eruption, and then we had more and more explosivity the more gas we added to the system. And so volcanoes behave in a similar fashion. More silica traps more gas, which causes the pressure to build up inside the volcanic system, and eventually that pressure is released as an eruption. Let's not go near eruptions like this in our lifetime. Thanks very much. I hope you enjoyed it. Talk to you next time. So did we do